So, good morning, children. Let us continue our session. So, what did we discuss in the previous session? We discussed about the first category of hydrocarbons, that is alkane. So, what kind of bond does an alkane show? It shows the single bond between two carbons, and we have named it, isn't it? So, what is the root name of a single carbon? Meth. So, methane. Similarly, two carbon hydrocarbon is called as eth, and 3 carbon prop, and 4 carbon but, isn't it? And then from there onwards it continues with the Greek names, that is pent, hex, hept, oct, non and dec. Okay, and but the prefix will differ from the bond to bond. If it is a single bond, we are naming it as what? Ane. So like methane, methane, ethane, ethane, propane, propane. Okay, so we learned how their structures are constructed. Now let us today learn about the double bond hydrocarbons, which are ending with the name ene. Okay, so now as we discussed earlier, children, in what are we talking about the bonds? We are talking between carbon and carbon, whether it is a single bond, a double bond, or a triple bond. So now, since I said a double bond between carbon and carbon, can I expect a alkene of a meth group? No, certainly not, because a single carbon cannot show a double bond. So that is why we don't see, or there is no alkene and alkyne of meth group. Okay, children, because there should be a double or a triple bond existing between two carbons, which is not possible with a single carbon. So that means the simplest alkene will start with the two carbon hydrocarbon, that is which one? Eth. Okay, so now I understood that my root name is what, children? Eth. Okay, so root name is what? Eth. Now, since it contains a double bond, the name will be completed as what? Ethene. Eth plus ene is what? Ethene. Now, let us see how does the structure of an ethene look like. So, as I told, step 1. First, show the bond between carbon and carbon. Okay. So, one carbon and second carbon. Now, since it's an alkene, so how many bonds should be there? Double bond. Two bonds. Okay, so that means how many electrons are satisfied, children? Two electrons. So now count. So as I told you, a link between any two elements. Now since here we have carbons, the link between between two carbons is common for both. So that means how many now? Two electrons are being satisfied. Still, how many more electrons are left off? Two more electrons for each of the carbon. So let me start with the first carbon. So first carbon, already two are satisfied. So that means how many more are left? Two more are left. Now since it's the first carbon, it can no more be bonded with any other carbon. Hence, the remaining two bonds will be linked to whom? Will be linked to hydrogen. Remaining two electrons will be shared by hydrogen. Now count 1, 2, 3, 4. So the first carbon is being satisfied with 4 bonds. Now coming to the second carbon. Since it is a 2 carbon hydrocarbon, so there further this will not continue with the next carbon. So this also, how many more electrons it is having for sharing? Two more electrons. So that's why this also will share with two more hydrogen atoms. So now 1 and 2, 3 and 4. So are they all satisfied? Yes. Okay, children. So now let us write the formula. So what could be the formula? As I told, the skeletal formula is CH. Okay. Now how many carbons? Two carbons. Now let us count hydrogens. 2 and 2, 4. So C2H4. Okay, and this is the simplest alkene compound. Okay, what is the simplest alkene compound? Ethene. Now this ethene is also called as ethylene. Okay, about this we'll be talking later. So right now just remember, it is commonly called as what, children? Ethylene. Now, the IUPAC name is what? Ethane. Now, what is IUPAC, children? IUPAC is nothing but it's a union of International Union of Pure and Applied Chemistry, which is going to name the various compounds. Okay, so like you have learned in biology about the nomenclature, How naming is done in the same manner, even there is naming done for whom, for these hydrocarbons, and it is done by whom? By IUPAC. So what is the IUPAC name of this hydrocarbon? Alkene ethene, a 2-carbon hydrocarbon, but commonly it is called as what? Ethylene or ethylene. Fine, children. Now let us go to the next hydrocarbon with the 3 carbons. Okay, so and the root word, as I told you, root word remains the same. Now what is the root word? Root word is prop. Okay, now since it's a double bond, it will end with what? Ene. Propene. So propene. What is the root word? Propene. Root word is prop and my prefix is what? In. So the full name is what? Propane. And how many carbon compound it is? It's a 3-carbon compound. So now let us draw the structure. So how many carbons, children? 3 carbons. As I told, step 1, I have to show, first show always a single link between all the existing carbons. So how many carbons here in case of propene? 3. So 1, 2, 3. Now it's what kind of hydrocarbon? A alkene, a double bond hydrocarbon. So now let me show the bond to the between the double bond between first and the second carbon only. Okay, children. Now about where can be the position of the double bond can be existing, we will talk about it later. Right now just let us place this double bond between the first and the second carbon. In every hydrocarbon what all you are going to now construct, please place the double bond between the first and the second for our convenience of understanding. Then later on how the position will be varying, we'll talk later. So now we have given a double bond. Okay, children. So now let us start again counting. So first carbon, how many electrons are satisfied? 2. So that means how many more are left off? 2 more are left off. So let me show those 2 bonds. So since it's a first carbon, it will be bonding with whom? With 2 more hydrogens. So the 2 bonds are 2 more electrons are satisfied by 2 hydrogen atoms. So now let us count 1, 2, 3, 4. So first carbon is satisfied. Now let us move to the second carbon. Now second carbon you see now 1, 2. Still there is one more. Okay, observe. So the middle carbon is linked to 2 carbons. Okay, so 1, 2 and 3. So that means still how many more electrons it is left to be shared? 1 more. Out of 4, 1 more. Very good. So then it will be shared by whom? Shared with whom? With the hydrogen. Okay, children. So now let us move. Now this is also satisfied. Let us again count 1, 2, 3 and 4. Fine. Now let us come to the last carbon, third carbon. Now how many how many electrons are satisfied? 1. Okay, because there is only a single bond. So that means out of 4, 1 is satisfied. So how many more existing? 3 more are to be satisfied. So that 3, since it is a terminating, it will be satisfied with whom? By bonding with 3 more hydrogens. So 1, 2, 3. Now let us count again. 1, 2, 3, 4. So is this carbon also satisfied with 4 electrons? Yes. Okay. So now let us come back to the formula. So how to write the formula? As I told, skeleton is CH, general skeleton. Now how many carbons, children? 3. Let us count the hydrogens. 1, 2, 3, 4, 5, 6. So C3H6. Fine. Okay, so this is the formula of whom? Propene. Okay, now let us go to the fourth one, that is